Hi, my name's Stewart Lynch, and in this video I'm going to show you how you can add the new UI calendar view that was introduced in iOS 16 for UIKit into a SwiftUI project. Thanks in this video should go to Chris Wu, who wrote and published an article on this topic. His article, along with the contributions from others that he mentions in his article, have made this video possible. I'll leave a link in the notes below. Of course, I've added my own twists. We're going to convert a simple list view of events that have a date property along with a string and event type to a calendar view displaying decorations around the dates where events occur. I'll show you how you can ensure that when you add, update, and delete events, their position and decorations on the calendar will update as well. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. As mentioned, there's a starter project for this tutorial, and I recommend that you download it from the link in the description below and work along with me. I'll walk you through the code now, but will not spend a lot of time on it. I'll point you to other tutorials of mine where I cover a particular technique in more detail. It's important to note that you must be using Xcode 14 or later if you want to follow along. And at the time of this recording, I'm using Beta 2. Starting with assets, you'll see that I'm using the new single app image icon introduced for Xcode 14 to create my app icon. And I've also uploaded an image that I'll call launch screen. This is used in my launch screen storyboard. And I've changed my project settings to make sure that I display a launch screen that uses this image. In the app entry point, I create a state object of a type event store with a preview property set to true, and then I inject it into the environment. Now, event store is an observable object that has two published properties: events, which is an array of event that I'll get to in a minute, and a preview, which is a bool. In the initializer, I set the preview to false by default so that I don't need to enter it. But as you saw in the app entry, it's set to true. And this is because when I initialize this class, I'll call a fetchEvents function. If preview is set to true, I can load some sample events, so this means that if I run on the simulator, I'll see those sample events. If I didn't set preview to true, I'd have to load data from a persistent store. So having mock data for preview during development is really handy. And you can also use this all the time in previews for your screens, as you'll see. There are other functions here that handle the CRUD operations of adding, deleting, and updating events in the array. Now, event is an identifiable struct that has 4 properties, one of which is an event type with 5 cases, along with an icon which uses an emoji associated with each case. There is also a date and a note property that we can use. When preview is set to true, I use this static array of events which I fetch and assign to our store's published property. The Start tab view is the entry view, and you can see all of my events listed in the list. This is possible because of that preview provider, and I set the preview to true for the environment object as well. If I remove the preview, all the objects disappear. That's the power of having a preview for an initializer. The calendar tab is basically empty, and that's going to be the purpose of this video. Back in the list view, I see I can swipe on a row, and it will call the store's delete function and remove it from the array. The Edit button brings up a form that allows me to update the event, and it will call the store's update function. I also have a toolbar button that will bring up the same form, but this time it's going to allow me to create a new event and call my store's create function. The updating and creating of new events is handled through a method that I've covered in this video here, where I use the same form for both processes. I'll leave a link in the description below. In order to use a UIKit view within a SwiftUI based app, we need to use the power of UIViewRepresentable. Now, I'll step you through the code here, but if you want to get a more in-depth explanation, I recommend that you watch this video here that I created. I'll leave a link in the notes below. So let's create a new file and call it calendarView. We'll need to import SwiftUI. Within there, create a struct called calendarView and make sure that it conforms to the UIViewRepresentable protocol. We'll let Xcode fix the error that's generated, and it creates a type alias, and we can assign the UICalendarView as the alias. This now creates a second error, but this will allow us to generate two functions. And it uses that type alias to create the return value. So we can now remove this type alias. We'll leave both functions empty for now. Now, a calendar needs a time interval so that we know how far in the past and how far in the future we want to view events. So I'm going to create an interval property, and that'll be assigned when the view is instantiated from SwiftUI, and it's a date interval. Within the makeUIView function now, we'll initialize the view as a UICalendarView. Then we'll set the view's calendar property to be a calendar with the identifier Gregorian. We follow that by setting the view's available date range to be that interval that we just defined. And then we can return the view. Well, now that we have our UIViewRepresentable for our calendar view created, we can use it in SwiftUI. So in the event calendar view, let's replace this text view with a calendar view. And that's going to require a time interval. Now we want to display events forever in the past as well as into the future. So we can use the constructor that requires a start date and an end date. And for those, we can use the distant past and distant future, respectively. Right away now, a calendar view is created and takes up the entire screen. And I had a real problem trying to set a frame for this view, but what I discovered that is if you embed it within a scroll view, it collapses down to give me exactly what I want. And it being a scroll view, when we add our event decorations or icons where events occur, it'll expand accordingly. And because it's a scroll view, it'll scroll if necessary if we have additional content. In fact, let's add an image below the calendar. And there's no need to embed in a Z-stack. Within the scroll view, I'll add an image using the launch screen image. I'll make it resizable and scaled to fit. And for this, I'll set a frame with a width of 100. Now, we're going to have to pass in all of our events to our calendar view. So, first, within this events calendar view, we'll need to get access to our events store to get those events. And that's an environment object. And then to stop the preview from complaining, we'll inject it into the environment here as well and make sure that we set the preview to true so that we'll be able to see content within our preview provider. Well, we need now to work more on the calendar view to be able to accept that environment object and use it to present the day decorations showing when we have events. So within the calendar view, we'll create an observed object that will be our event store. This is going to cause a problem now back in our events calendar view. So we'll have to go back there and make sure that the initializer passes in that environment object that we created here into our calendar view. Switching back once more now then, in order to display events in our calendar, we'll need to be able to access the UICalendarView's delegate functions. And this requires a coordinator class. So within the calendar view, we'll create a new class and call it coordinator that will conform to the NS object and the UICalendarView delegate protocol. Well, this creates a couple of errors. In CalendarView, let Xcode fix this issue in the CalendarView by creating a MakeCoordinator class. I'm going to move this down below the MakeUIView function. Within the Coordinator class, we'll let Xcode create the required CalendarView function. Both of these functions require that we return something. I'm going to temporarily return nil in the Coordinator function just now to stop that error. To communicate between the CalendarView and the Coordinator, we can create a property in the Coordinator that we'll call a parent, and it will be a CalendarView. This is also going to have access and be able to make modification to the events. So we'll need access to our event store's observed object too. This is going to require an initializer for the class, so we can let Xcode generate that for us now in Xcode 14, but it doesn't do it exactly right, because event store is an observed object. So we'll have to specify that as an observed object. And then we'll need to use an underscore so that we can access the underlying properties. Now, in the MakeCoordinator function, we can create and return an instance of this coordinator, passing in self as the parent and the event store, again using the underscore in front of that observed object event store. The CalendarView function is what we use to create the icons or decorations that will be displayed where events are happening on particular days. And this is going to be updating the UI, and it'll need to be executed on the main thread. So we'll annotate it with main actor. I'm also going to need to find dates regardless of what the time of day that the event occurs. I want to ignore the time, so the best way to do that is to create another extension on our date extension that I created to generate random dates, and it's going to return the start of day of any date, so that when I compare two dates, it's going to always compare the two starts of days. So in our extension, we'll create this variable called start of day that will return a date, and it's simply the calendar.current.startofday for self. So now we can create the decorations for our dates where events occur. First, I want to determine if there are any found events in our store for that date, represented by the date components, which is an argument for this function. So we can use a filter function on this, where we can compare the iterated event's date, start of day, to the compared date components, date, start of day. And if it's empty, we'll just return nil. If the count is 1, we'll want to return a UICalendarView.decoration. And we have a number of different options to choose from. And I'm going to choose the image case and just use a UI image of a system image named doc on doc fill. And this will be an indication that there is more than one event on a day. And I'll set the color to red and the size to large. The remaining option then is when we have a single event. And this will be the first one of the found events array that we filtered. So we can safely unwrap it because we've covered the other options. For this time we're going to use a custom view case and return a UI label that we'll call icon. And for the icon or label text then, we'll use our single events event types computed icon property, which is a string that's that emoji. And then we'll need to return that icon for our custom view case. The last thing we need to do here then is to go back to the calendar view where we made this view and assign the coordinator as the delegate. The content that is the MakeUIView's argument is aware of that coordinator. so we can make that argument right after we created our view. If we return now to our SwiftUI view, then you'll see that the icons are being displayed where events occur. And notice this one on the 29th must have more than one event occurring because it uses that red symbol dock-on-dock image. The next step then is to display the events when I tap on them and allow us to edit and add new ones. In order to display our events, we're going to need to know what the date is. So we'll have to tell our coordinator what type of date selection we want. Do we want a single date or a multiple date selection? Well, in our case, it's going to be a single date selection. So we'll need to let the coordinator conform to the UI calendar selection single date delegate protocol. This creates an error, so we'll let Xcode generate that stub for us. Let's move this first down below our main actor function. This dateSelects function requires the didSelectDate as date components. We're also going to need another date selection function that's going to let us know if we can select a date. So let's create that one too. And we'll just return true. In MakeUIView, we'll need to create an instance of the UICalendarSelection single date object. And we can specify our delegate as the context coordinator. And then we can set our view's selection behavior to that object. The date selection functions both accept an optional date components object, and these are the date components for the selected date. So we'll have to pass that back to our SwiftUI view so that we can present the corresponding events. Well, we can do this by setting up a binding of those properties between our SwiftUI view and this calendar view. So we'll need one for our selected dates, date component, along with a Boolean property to trigger the presentation of our modal sheet that'll display the events on that day. So back in Events Calendar View, we'll create those two state objects. The first being date selected, which is our optional date components, and the second state variable will be the display events Boolean that we'll set to false initially. Back in our calendar view then, we'll create bindings to these in the coordinator class. A binding, which is a var date selected as an optional date component, and another binding for that display events, which is a Boolean property. So then we're going to have to go back to the events calendar view, where we'll need to add these properties to when we instantiate our view. Well, now that these pieces are in place, we can return to the coordinator and complete the function that happens when we select the date. First, we'll need to check to see if our date components is not nil, meaning we've selected a date. And we can use a guard check for that and return if it isn't. Next, we can use the same function to create an array of found events. Then we can check to see if it's not empty. And if it isn't, we can toggle our display events Boolean property. And then finally, I almost forgot, we need to set our parent date selected property to the date components. The coordinator class is now complete. So we can now create our sheet that we can present when a date is selected to display these events. So I'm going to create a new SwiftUI file that I'll call Days Events List View. Now this form is going to require access to our event stores environment object. It's going to also require the date selected, which you will recall is a set of date components. And we're going to have an edit button on the row of events so that we can tap on it to edit it. And for this presentation, I'm going to use a method that I talked about earlier. And I've created a video for this on the dual purpose form presentation, where I want to use the same view for both editing and updating new events. So I'm going to create a private variable that I'll call form type, that is an optional event form type. Now, the creation of this view itself is pretty straightforward, so in the interest of time, I'm going to blitz through this and speed up the video to create it, and then I'll walk you through what I've done in just a second. So here's what I just did. I created a navigation stack, and inside there, I used an if-let to unwrap the optional date selected. I embedded this in a group so that I can apply a navigation title modifier. You can't do that on an if clause, so that's why I embedded in a group. I then determine the array of found events and present them in a list using a for each loop. And I use the same list view row that I used in the original starter projects list, and I attach a swipe action to each of the items in the row, and that's going to allow me to delete an event. The form type property is changed when I tap on the edit button on the list row, and it's bound to the one on this view, which allows me to present a sheet using that item constructor. In the preview provider, in order to show one of the views in the preview, I first have to create a static set of date components for a sample date. And I'll just use the current date. Then I can pass this as a constant binding when I instantiate the preview version of this view. And then to make sure that I see items in the preview, I set the preview option to true for the environment object. So now I can return to the events calendar view and attach a sheet modifier to the scroll view that'll be activated by the bound display events property that is toggled when we tap on one of the dates that has any events. When it is, we can present the day's events list view, passing in that date selected, and then use the new iOS 16 presentation detents property to pass in an array of medium and large to present either a half or full sheet from the bottom. Let's test this now to see what happens when we tap on one of those dates that have a decoration. We see in our calendar all of the events on those days. I see a single event on the 27th, so when I tap on it, I see a single item in my list. On the 29th, there are 2 events. Let me edit this football game to make it a soccer game. So far, so good. Everything looks great, and it seems to be working. There is a problem, however. If I change the icon or change the date of a particular event, it's not reflected in the calendar itself. We need to be able to reflect changes and refresh this calendar when either the decoration changes or a date changes. To fix this issue then, we'll need to introduce 2 new properties to our events store. These will both be optional published properties which will be assigned when events changed. The first one we'll call changed event, which is an optional event, will be assigned whenever we update or delete an event. But we'll also need to know if a date changes on an event, and that means we're going to require the knowledge of the 2 different dates. So I'll create a second published property that I'll call moved event that will be an optional event. Then, in the function here where we delete, we can assign the discarded result that comes from when we remove an event to the changed event property. On the add function, we'll set changed event to the event. In the updates function, we'll need to assign the original event before updating to the moved event, and then after it's changed, we'll assign the changed event. So first I'll assign the event at the specific index to the moved event, and then after event editing and changing the information, I assign that event to the changed event property. Now we'll need to revisit the empty update view function on our calendar view. We're going to have to call the view's reload decorations function for the particular date. But you may recall that our event decorations use date components, whereas our event only has a date. So this is going to require the knowledge of the particular date's date components. So let's just go back to our model for our event and create a new computed property for our date components for our date. Now, when I sped through the creation of that view for presenting the list in our calendar, I had a preview property called date components. Well, it turns out it's the same thing. So let's just copy that. And then instead of this fixed date, it's going to be whatever the date is for our model. We can return now to calendarView then and the update view function. So I'm going to use an if-let to unwrap the changed event, and we can then call the UIView's reload decorations for date components using the changed events date components and set the animation to true. And then we'll set the event store change event back to nil. And we can do exactly the same thing for the move event. This will fix the problems that we had, as you'll see in just a second. But let's do one more thing. We need to add a toolbar button so that we can create new events on our calendar. So to trigger this, we'll need to add an identifiable object that will be our form type, which is that optional event form type. And then this will trigger the presentation of the form to create the new event. So we'll attach a toolbar to our view, and then we'll create a toolbar item with the placement being a navigation bar trailing. And then we'll use a button with an image. And we can use a system image of plus.circle.fill. And I'll set the image scale to medium. So for the action then, we can assign the new case of our form type to initiate the presentation of the form. So in order to present that, we'll need a sheet modifier using the item, which is our form type, and then using the shorthand to present the view. If this looks a bit strange to you, I really recommend you watch that video that I referenced earlier. Let's test this on the simulator now then. Let me change the date of this football game to the 28th and set the correct start time. I'll update the event, and I can see that it's moved on my calendar now. If I'd changed the event type, the icon decoration would have changed as well. You might want to test that. Let me try creating a new event. How about we create an event for July the 4th at 6 p.m. I think it's going to be a party. And that's a social event. Let's add it. I see that it gets added to my calendar on the correct date with the correct party decoration. Wonderful. Now, if you ever need to display events in a calendar using SwiftUI, you can. I hope you found something useful here that you can use in your own projects. If you found the video helpful, please give it a thumbs up and leave a comment. Thanks as always for taking the time to watch, and I'll see you in the next video.